Hi, we had a request from 11Q3 to look at bond making and bond breaking. This comes up in the C5 module where you will have looked at endo and exothermic reactions and diagrams like this. And you can see from the diagrams, the reaction profile, whether it's endo or exothermic. But we can also do calculations using data to work out if it's endo or exothermic. So that's what I'm going to focus on in this video. So, here is an exam question. We're told that methane reacts with chlorine in the presence of sunlight and we're given the reaction. Some bond dissociation energies are given in the table below. So they will always give you this data, they don't expect you to memorise these numbers. And the question says, show that the enthalpy change for delta H for this reaction is minus 103 kilojoules per mole. Now what's quite nice is that they've given you the answer, so you know what number you're aiming for, and that's always a good clue. But when we look at these, we need to think about what are the bonds being broken and what are the bonds being made. So the bonds being broken are all these bonds on this side with our reactants. Every single one of those bonds is going to be broken, and then we're going to have our bond made over there, and that's every single bond being made. So we presume that all these bonds, even though we've got the CH bonds here still intact on both sides, we do presume they're all broken. So let's look at the bonds being broken first. So bonds broken. So we have got some CH bonds here, and I've got 1, 2, 3, 4 of them. And if I use the table, that energy comes to 4 times 4, 1, 3, which equals 1652. The other type of bond being broken is a chlorine-chlorine bond, and there's only one of those. So that's going to be 1 times 243, which will be 243. Now if I add these two numbers up together, I get 1895, and that is the energy required to break all the bonds present. So if I then look at bonds being made, I have got 1, 2, 3 carbon-hydrogen bonds. I've got 1 carbon-chlorine bond, and you'll notice I'm crossing them out so I know that I've counted that bond. And then 1 final bond, the hydrogen-chlorine bond. Again, I only have one of those. And that gives me a grand total of 1998 kilojoules per mole. Now, you can see I'm writing down all my method, because typically you get a mark for calculating the bonds broken and bonds made. And it's a really good idea to show your method in case there's any errors carried forward. You then got to work out the delta H. Well, delta H is going to be basically bond making minus the bond breaking. Bond breaking minus bond making. The bond breaking, it requires energy to break bonds. That is an endothermic process. We kind of leave it positive. And we take away the bond making, that typically releases energy. So that's why it's bond breaking minus bond making. So we are going to have 1895 minus 1998, which gives us minus 103 kilojoules per mole. And that matches our answer up there. Other information we can say, because it's a negative delta H, we can say this is an exothermic reaction, and sometimes they ask you that in a forward going question. Right, so that's question 1. I'm going to pause the video here and I'll see you in the next video.